Intro to LAN, local area network. We have here I see that it opens automatically a small application that will display the network topologies. Let's see. LAN topologies, local area network topologies. Over the years, there was been experimentation and implementation of various network designs. In reference to networking, when we refer to the term topology, we are actually referring to the design or look of the network at hand. Let's discuss the advantages and disadvantages of these topologies below. So this lab will display the topology flows. Okay, we have the ring topology. All right. The ring topology, also known as token topology, boasts some similarities. Devices such as computers are connected directly to each other to form a loop, meaning that there is a little cabling required and less dependence on dedicated hardware, such as within a star topology. As you can see, PCs are using this is a bus topology, a little cabling compared to a star topology. Now, let's see. A ring topology works by sending data across the loop until it reaches the destined device, using other devices along the loop to forward the data. Interestingly, a device will only receive data from another device in this topology if it does not have any to send itself. If the device happens to have data to send, it will send its own data first before sending data from another device. Because there is only one direction for data to travel across this topology, it is fairly easy to troubleshoot any faults that arise. However, there is a double-edged sword because it isn't an efficient way of data traveling across a network, as it may have to visit many multiple devices first before reaching the intended device. Lastly, ring topologies are less prone to bottlenecks, such as within a bus topology. As large amounts of traffic data are not traveling across the network at any one time. The design of this topology does, however, mean that a fault, such as a cut or a cable, or as a cut cable, or a broken device, will result in the entire networking breaking. In a ring topology, all devices are a connector to two other to create a full cycle. Packets of data travel from one device to the next until they have reached their destination. Okay, we know that. One of the major flaws within a ring topology is that if a device goes down or a cable is broken, the data will no longer be passed. If you if you have the middle network cable, you can cut it and see what happens. Okay. Done. The data from this PC can no longer travel to the following devices. The packets can now no longer travel around the network, and no device can talk to each other. The bus topology. This type of connection relies upon a single connection, which is known as the backbone cable. This type of topology is similar to the leaf of a tree in a sense that devices, like leaves, from devices stem from where the branches are on this cable. Yeah. Because all data destined for each device travels along the same cable, It is very quickly prone to becoming slow and bottleneck if devices within the topology are simultaneously requesting data. This bottleneck also results in very difficult troubleshooting because it quickly becomes difficult to identify which device is experiencing issues with data, all traveling along the same route. However, with this said, bus topologies are one of the easiest and most cost-effective topologies to set up because of their expenses, such as cabling or dedicated network equipment used to connect these devices. Lastly, another disadvantage of the bus topology is that there is little redundancy in place in case of failures. This disadvantage is because there is a single point of failure along the backbone cable. If this cable were to break, devices can no longer receive or transmit data along the bus. All devices are connected to a single cable, often called the backbone. Data is sent in both left and right directions down to the backbone until the packet's destination is reached. A major flaw in this topology is that it can't handle a large amount of data. On the next step, send as many packets as quickly as you can to try to take down the network. This bus network is now down. The start topology. The main premise of a star topology is that devices are individually connected via a central networking device such as a switch or hub. This topology is the most common found This topology is the most commonly found today because of its reliability and scalability despite the cost. Any information sent to a device in this topology is sent via the central device to which it connects. Let's explore some of these advantages and disadvantages. Because more cabling and the purchase of dedicated networking equipment is required for this topology, it is more expensive than any other topologies. However, despite the added cost, it does provide some significant advantages. For example, this topology is much more scalable in nature, which means that it is very easy to add more devices as the demand for the network increases. Unfortunately, the more the network scales, the more maintenance is required to keep the network functional. This increased dependence on maintenance can also make troubleshooting faults much harder. Furthermore, this star topology is still prone to failure, albeit reduced. For example, if the centralized hardware that connects devices fails, these devices will no longer be able to send or receive data. Thankfully, these centralized hardware devices are often robust. Every packet is sent through this switch, which means if the switch goes down, the network will no longer work. See if you can somehow break the switch. Yes. There you go. Switch broken. All right. Okay, we read about the star, the bus, the ring. What is a switch? Switches are dedicated devices within a network that are designed to aggregate multiple other devices such as computers, printers, or any other networking cable device using Ethernet. These various devices plug into a switch port. Switches are usually found in large networks such as businesses, schools, or similar sized networks where there are many devices to connect to the network. Switches can connect a large number of devices by having ports of 4, 8, 16, 24, 32, and 64 for devices to plug into. Switches are much more efficient than their lesser counterpart hubs and repeaters. Switches keep track of what devices is connected to which port. This way, hubs and repeaters don't have this functionality. This way, when they receive a packet, instead of repeating that packet to every port like a hub would do, it just sends it to the intended target, thus reducing network traffic, which is great. Both switches and routers can be connected to one another The ability to do this increases the redundancy, the reliability of a network by adding multiple paths for data to take. If one path goes down, another can be used. While this may reduce the overall performance of a network because packets have to take longer to travel, there is no downtime. A small price to pay, consider the alternatives. What is a router? It's a router's job to connect networks and pass data between them. It does this by using routing, hence the name router. Routing is the label given to the process of data traveling across networks. Routing involves creating a path between networks so that this can be successfully delivered. Routing is useful when devices are connected by many paths, such as in this example below. From computer A to computer B, we have different routers. What does LAN stand for? Local area network. Let's copy this, which I presume is the last one. All right. What else? Let's see. What is the verb given to the job that routers perform? Routing. Pretty hard. What device is used to centrally connect multiple devices on the local network and transmit data to the correct location? Switch. What topology is cost efficient to set up? The bus topology. What topology is expensive? The last one. Not the star one. What was the last one? Ring topology. The star topology, sorry. The ring one is not that expensive. It's the cheapest actually.